Chapter 3, Introduction to PACS. So most of you, if not all of you, have had some type of interaction with PACS in the workplace. If you are a radiology tech that is working in the everyday field, you'll know that this is a pivotal part of your everyday workflow. A PACS is a picture archiving communications system. So it stores, distributes, and displays medical images for review and interpretation. Everyone uses this, from the radiology tech to the radiologist to the PACS manager to the radiology film staff, but everyone essentially has to access the PACS at some point. It replaces all standalone single modality workstations, and it integrates with a hospital's IT infrastructures. So as you can see in the diagram right here, so you start with your each different modality, MRI, CT, and X-ray, just for this picture here. So that is operated by the operator, and then all the images are sent down to the PACS, and the images are sent through the way of DICOM images, which we'll get into later, and it integrates with the RIS, and then those images from the PACS can be viewed by the radiologist at his or her workstation. A radiology information system is one of the core components of a digital radiology department. It is called the RIS. It is software that manages the day-to-day operations of a radiology department. There are essentially hundreds of vendors to choose from out there that have different RIS systems to sell to hospitals. The RIS can be bundled with other hospital information systems, but it must receive the information from the hospital information system seamlessly. You want the RIS and the HIS to work together and be interoperable. The RIS must allow the radiology staff to enter and modify orders, and it utilizes the HL7 as its core communication protocol. We will get into HL7 a little bit more later. There are different parts to a PACS. It archives the DICOM modality data. The PACS database actually supports the powerful patient search and the study matching tools. So this could include patient demographics, reports, study description, where images were obtained, like on different modalities, and where images are actually stored. There is networking equipment that is involved. It's usually 1 or 10 gigabytes in between large nodes of the enterprise. The networking equipment segregates the PACS data traffic from other traffic that may be going on in the enterprise, which allows for high performance and reliability. A PACS broker is software that converts and translates between HL7 messages for HIS and RIS and the DICOM transaction for PACS. The broker will generally provide DICOM capabilities to components within the PACS network that uses DICOM. So DICOM stands for Digital Imaging and Communication in Medicine, and it is the standard format for PACS files and messages. So in order for an image to go to PACS, it needs to be in DICOM form. So with the implementation of PACS, the clinicians or referring doctors who typically can have access to view film-based images, they just come over to the department, or they request the images and the radiology department sends them over and they can view their images up on a light box. So when PACS is now implemented, they lose the function to do this. But that's not acceptable. So it is extremely important that these clinicians have access to the images and reports wherever they may be. Since large data sets from PACS would bog down, any wide area network, data compression needs to take place. Data compression allows the clinicians to view the large image sets on PACS from remote locations with relatively low speed network connections. There are two main types of compression, and we will talk about these types of compression throughout the whole chapter, so it is very important to get to know these types. Lossless compression has absolutely no image degradation, and it has a 2.5 to 1 compression rate. Then there is lossy compression, which has a much higher compression rate, which is better. It has a 10 to 1 or more. But the thing with lossy compression is that there may be image degradation when the compression takes place. And lossy compression is recommended only when images won't be used for primary interpretation. So if a radiologist is looking at an image, you do not want the image to have or require any sort of lossy compression. But if a clinician is just reading a radiology report and sees in the report what the problem is and wants to just correlate that with the actual image, he can pull up the image and it can be a lossy compression image because he is not actually interpreting the image. He is just correlating what he sees on the report to the image. Diagnostic workstations are used when PACS is implemented. Diagnostic workstations are high-performance computers where the radiologist accesses the workflow. So if you take an image and it shows up on your screen, that does not mean that it is a diagnostic workstation. The radiologist really needs the diagnostic workstation because they're making a primary interpretation from the image. The diagnostic workstations can be generic workstations that have a DICOM viewer on them, or they can be specific computers from each PACS vendor. Diagnostic workstations have high resolution and high brightness monitors, which obviously are needed when a radiologist is making interpretations. It holds and operates the study retrieval and study viewing software on the workstation. And it maintains separate direct links to PACS databases and PACS archives. It reduces the routing path for data and improves performance. A local PACS workstation is linked by standard networking to the PACS core and archive. So a diagnostic workstation has different functions. It allows assembly of sets of cases to be sorted, facilitates retrieval of new studies to be read from PACS core to the local memory, and it communicates with PACS core to retrieve the comparison studies. It views new and old exams. It can allow for image manipulation and is often linked to the dictation and reporting tools. And it changes the reading status of studies. So basically what that means is after a study is on the radiologist work list, picked off by the radiologist and read, it can then be viewed as a read study. So it changes the status. There are some core workflow elements that occur on PACS. So it captures, validates. There are some core workflow elements that occur on PACS. The first is capturing DICOM studies. So the digital modalities capture the actual DICOM images. This includes all types of modalities from CT, MRI, PET, general radiology to, all types of the modalities. So then it actually validates and confirms the DICOM data versus the HL7 order using the PACS broker. Another workflow element is just storage. So the PACS stores studies using the industry standard processes generally accepted by IT. Then there is retrieval and display. So the PACS allows for the retrieval and display of current exams by radiologists via PACS diagnostic workstations, which we just talked about. Another example of retrieval and display is when a radiologist wants prior studies. So the PACS also has the function to retrieve and display prior pertinent studies. Another core workflow element of PACS is that it prevents more than one radiologist from reading a particular study. I touched a little bit on that on the last slide. So once a radiologist starts the dictation, the instant notification is transmitted back to the core, triggering that exact case to be hidden from other radiologists to read it. So once radiologist A picks up the case to be read off of the work list, it allows for radiologist B and C to not be able to see it, so they cannot even pick the exam to read. PACS also supports PACS users. So the PACS users are, they could be the radiologists, technologists, the clinicians, and those are really the core customer base of PACS. And if these three groups are satisfied, then all is well with the world. So when you see PACS being implemented at your hospital, most hospitals have already implemented a PACS, or if not, they're in the process. You'll notice that a whole workflow can really change, and new professional roles are created simply by the implementation of a PACS system. We're just going to review a few of the roles that can be created. The first is the most common, which is the PACS administrator, and the PACS admin is generally the first person needed to support a PACS in a system. So they are responsible for the day-to-day operations of PACS. They are the go-to person if you have a problem. They're familiar with the radiology workflow already, and if there are any PACS errors, they are able to fix the workflow errors that occur with PACS. They often understand how to use PACS to ensure the workflow for users is optimal, so they are extremely helpful to you when PACS is implemented. They carry out basic PACS functions, so they help with PACS image transmission, display, archival, that type of thing. All right, next is the image service rep. So these types of staff aren't necessarily engaged in all hospital settings, so usually larger hospitals use them in the film world. So these are thought of as film librarians. They perform much of the same functions as they typically did in the film world, so they're kind of a crossover to the digital world as well. They are the types of people who locate exams, track studies, provide images to patients and physicians requesting access, and they ensure all data is necessary for interpretation of the exam so the radiologist can actually read it. Then there is the PACS system analyst. These types of people manage the back end of the PACS application, so they respond to system issues that fall outside of a normal day-to-day operations. So anything that the PACS administrator does not take care of, the PACS system analyst should. They work very closely with the PACS vendor to solve PACS problems. So they're commonly thought of as the more techie person in a professional role created by PACS. Then there is the clinical outreach and user training individual. So whenever a PACS is implemented, the staff has to know how to work it. So if you have this great, awesome new system like PACS, but the staff doesn't know how to use it, it's no good. It is essentially useless. So the trainer coordinates with the users inside and outside the PACS facility and facilitates the training process. They give advice on networking and firewall access, and they provide the training for the RADs and the clinicians as well. Okay, so when a PACS is implemented at a site, new functionalities are often used. So one of them, Nighthawk readings. I am sure some of you have worked off-hour shifts where it's basically at a medium to small hospital where a radiologist is not on site to read all of the studies. So you have to utilize the Nighthawk readings. These are preliminary or final interpretations provided outside the normal radiologist reading hours. Typically, this is after the first shift radiologist has left and the readings occur on the late afternoons or nights and the weekends where a radiologist is not staffed on site. This is widely used by most hospitals in the U.S. The radiologist or the site usually pays the Nighthawk radiologist per exam to read the studies. They're useful, like I said, for the smaller hospitals that don't provide the 24/7 radiologist coverage. Then there is site-to-site DICOM image transfer. This is image data that is transmitted between different PACS systems, and it's usually between two different hospitals or clinics. So if you have an organization and you have hospital A that has 3 different subsidiaries of it, clinic A, B, and C, data transmission you want to occur between all 4 of those sites. So this is what site-to-site DICOM image transfer is. It limits the need to transport image CDs from hospital to hospital. So it knocks out the courier role of an individual who would physically transport images in the film world from one site to another to be read.